Before we get into actually graphing, today we're going to focus more on sketching the graph. But before we get into that, we need to talk about some of those steps that we're going to have to graphing. So our first step is going to be the degree. This is all going to be to name it and give it shape. We know that the shape is going to be a parabola. The name of it will be always a quadratic. If it has two terms, it will be a binomial. And if it has three terms, it will be a trinomial. The next step is going to be, does it open up or down, this end behavior. If the a value is positive, it will open up. If the a value is negative, it will open down. Next will be to find the axis of symmetry, which in our ax squared plus bx plus c, if we take our b, which is the coefficient of x, and we make it the opposite and divide it by 2 times the a coefficient, or the coefficient of x squared, we will get our axis of symmetry, which remember will always be x equals something. Next, we will find the vertex. The x value will already have been found, in that we will have found that to get the axis of symmetry. And then to find the y value, we're going to take f of that value. Then we will find the y-intercept, which will always be 0 for the x-coordinate, and whatever our c value is in our quadratic function in standard form. And finally, we will talk about the domain and range, which, if you recall from 5.1 as well as chapter 1, our domain will always be all real numbers, and our range will always be y is either greater than or less than or equal to whatever our y value is within our vertex. So now let's take a look at an example to see how this in action. So we have here h of x equal to x squared plus 6x plus 5. And the first thing I actually want to do is identify our a, our b, and our c, which will make our lives easier when doing this information. A here is equal to 1. B is equal to 6, and C is equal to 5. So that being said, when we talk about the degree, know that this is a quadratic, which tells us that it is a degree of 2, and it has 3 terms, so that would make it a trinomial. The end behavior. Our a value is 1, which is positive, therefore it opens up, which means our basic look is going to be like such. For the axis of symmetry, x is equal to the opposite of b, which is 6, so negative 6, over 2 times a, which is 1. 2 times 1 is 2, and negative 6 divided by 2 is negative 3, so x equals negative 3 would be our axis of symmetry. For the vertex, our vertex is going to be negative 3, f of negative 3. We need to actually find out what f of negative 3 is. So taking our function here, we have x squared, so we're going to take negative 3 and square it, plus 6 times negative 3 plus 5. Negative 3 squared is 9. 6 times negative 3 is negative 18, so we have minus 18 plus 5. 9 minus 18 is negative 9 plus 5 is negative 4. So our vertex will actually have a ordered pair of negative 3, negative 4. Our y-intercept, as we have written over in the margin, is 0, c, and our c value is 5, so our y-intercept is 0, 5. Our domain, as we mentioned, is all real numbers, and our range, since it opens up, our vertex is a minimum value, which means all of our y values for the range are greater than or equal to our y value of -4. Now that we have this information, let's go ahead and graph this. I'm going to start with drawing in my axis of symmetry. And our axis of symmetry is at x equals -3, so I'm going to and then I'm going to proceed with graphing -3, -4, and we have a y-intercept of 0, 5. And I know one thing that's going to help me with sketching this is knowing that that axis of symmetry is halfway, and our y-intercept is that halfway, is on the other side, the same value as the other point, so we can create a symmetry. And like I said, this isn't going to be exact, but we can sketch our parabola. It doesn't have to be perfect, just so we have an idea of what it looks like.